I'm Pooja Arora, Assistant Professor at Bayani Group of Colleges. In my today's lecture, we are going to discuss some other important laws and principles of set theory. So here are some other laws of set theory. Let's start with the first one. The first one named idempotent law. The idempotent law of set theory. This law is we have two operations, union and intersection. And what is idempotent law? Idempotent law is nothing but it says that when we apply these operations, union and intersection, with the same set, means if I apply union on A union A, what will I get? I will get A again. And if I apply intersection on the same set, I will get A again. So this law is called idempotent law. When we apply the operation union on the same set, I will get the same set again. If I apply the intersection operation on the same set, I will get the same set again. So this law is called idempotent law. Okay. And the second law is called associative law. That it is a very familiar name for the maths students. What is associative law? Associative law is like this: A union B union C, that will be equal to A union B union C. This associative law apply on the both of the operation union and intersection, as well as if I write A intersection B intersection C, that will be equivalent to A intersection B intersection C. If we change the hierarchy of the parenthesis, it doesn't change the result. This law is called the associative law. And commutative law, I think you all know about this law. That commutative law said that if I apply operation A union B, and if I find the union B union A, the answer will be same. Apply union on A and B, apply union on B and A, answer will be same. Same with the intersection. A intersection B is same as B intersection A. So this law is called commutative law. Okay. And now moving to the next law. The next law is distributive law. Distributive law is if I apply like A union B intersection C, and the result will be A union B intersection A union C. Means I am distributing the union operation between B and C. So how will I get the answer? A union B intersection C is equivalent to A union B intersection A union C. Same I can apply on the intersection A intersection B union C, that will be equal to A intersection B union A intersection C. So this law is called distributive law. Okay. And the next law is called identity law. What is identity law? That we have two special set. The one is phi, that is null set, and the one is U, that is universal set. So if I apply the union and intersection operation with phi and universal set, what will be the answer? For example, if I take a union of A union U, that is a universal set, that is my set A. If I take union of these two, what will I get? I will get a universal set. But if I apply a union on A and phi, A is my set and phi is a null set, there is no element in this set. So if I apply union on these two sets, what I will get? I will get A. But if I apply intersection on both of the set, for example, if I apply A intersection U, intersection gives me the common elements. So if I apply intersection on my set A with the universal set, I will get my own set A back. And if I apply intersection on A and phi, phi has null element, so there is no common element between them, so phi will be the result. So this law is called identity law, in which we apply the union and intersection operations with my own set and universal set with my own set and phi set, with both union and intersection. So this law is called identity law. And the next and last one is called complement law. Complement law is, I have already discussed the operation of complement, how we can find the complement of a set. So if I find the complement of a set, that is denoted by A's power C, and if I find the complement of this set, the complemented set, I am going to again complement it, I am getting back my own set A. Okay, and if an union A is complement, that means what I am doing, I have already discussed the Venn diagram of complement. If you remember, this is my set A and this is the outer shaded area is the complement set. A is complement because this rectangle is a universal set. So this shaded area is the A's complement. Okay, now the laws is saying A union A's complement. This and this union, that will, what will be it return? It will return the universal set, the complete area inside a rectangle. Okay, so this law is called complement law. Okay, I'm not going to prove each and every law, and I'm not going to give an example, but you can take any law and take example. For example, if you take this example, A union B and B union N, let's take two sets. Set A equal to 1, 2, 3. Set B equal to A and B. If I take union A union B, what will I get? 1, 2, 3, A comma B. Okay, and if I get B union A, what will I get? I will get the same set. A, B, 1, 2, 3, and these two sets are exactly equal. So A union B is equal to B union A because the elements of these two sets are same. So this law proved. In this way you can prove any of the law. For example, if I take a universal set U, that will be equal to 1, 2, 3, 4 and 5, and I have a set A that is 1, 2, then what will be the complement set A? It will be equal to 3, 4 and 5. We have already discussed the definitions of complement, union and intersection, so I am not going to repeat this. So this is my set A and this is the complement of the set. If I take union of these two sets, A union A's complement, so that will be equal to 1, 2, 3, 4 and 5. So this is my set. What I get, I get the set again, the universal set. Okay, so this law is proved. And what is my complemented set? Complemented set is A's complement. What I get? This is 3, 4 and 5. If I want to take again the complement of this set, so the universal set is 1, 2, 3, 4, 5, and now my set is 3, 4, 5, and I am taking its complement. So what will I get? I will get 1 and 2. And what is this? This is my set itself, set A. So if I take the complement of any set and I take the complement of the complemented set, then I get my set back. So this law is called complement law. In this way you can prove each and every law if you want. You can take an example and you can prove these. The next law is the law of inclusion and exclusion. So this is a very important law because this law is also important for BCA and MCA students as well as the competition exams, because in competition exam you can find the questions related to this law. You can solve with you can find this type of questions which can be solved with the help of inclusion and exclusion. What does this law say? That if you want to find the number of elements in the union set, for example, the statement of the law said that n of A union B is equivalent to n of A plus n of B minus n of A intersection B. This is the statement of inclusion and exclusion principle. What does it say? It said that the number of element in the union set A union B is equivalent to number of element in set A plus number of element in set B minus number of element in the intersection of these two sets. That means the common element. We subtract the common element and we find the number of element in the union set. This inclusion exclusion principle is for two sets A and B. If you want to expand this principle, you can get this for the three set also. For example, if I want to find the number of element in A union B union C, what I will do? I will add the number of element in the single sets, that is number of n of A plus n of B plus n of C. Then I will subtract the common element between two sets. For example, n of A intersection B minus n of B intersection C minus n of A intersection C. And then I will add the third term, that will be equal to A intersection B intersection C. Look at the pattern in the formula. That's why the name is called inclusion and exclusion, because in this law we include some of the term and we exclude some of the term. We are including the term with one set, n of A, n of B, n of C, and we are excluding the term with two pair of sets, that n and A intersection B. We are excluding the term B intersection C and A intersection C, and again we are including the term with three set, A intersection B intersection C. So in this way we can expand the law for any number of set, for 4 set, for 5 set. You can get the number of element in A union B union C union D, and in this way you can expand this. Okay, and how to use this law, how to use this principle? For this we are having some of the example, and I am going to solve these examples one by one to get familiar with this law. This is my law of n of A union B, that will be equal to n of A plus n of B minus n of A intersection B. And the questions you are going to solve, very first question I am taking is, if I take a survey of a class and there are total 70 students in a class, from 70 students, 50 students like maths and 40 students like DBMS, and the question asked you that how many students like both the subjects, maths and DBMS. Suppose there are two subjects, maths and DBMS. Some of the students liking maths, some of the students liking DBMS, but there may be some of the students which are liking both of the subjects. So how can you solve this type of question? We are using inclusion exclusion principle to solve this question. What will I get? N of A union B, that is the total number of students in the class in the union set, that will be equivalent to n of A plus n of B minus n of AB. Well, AB is same as A intersection B, don't get confused with the symbols. We can write A intersection B shortly in AB. Okay, so we are going to solve this question. N of A union B we have given in the question. There are 70 students in the class. N of A which like maths. I am just supposing two set A which are liking students which are liking maths, and set B which are liking DBMS. Okay, so N of A means number of students, that are 50, number of students, that are 40, and minus N of A intersection B. A intersection B is common element between these two sets, that means the students who are liking both the subject maths and DBMS, and we have to find this factor. Okay, and what I get, N of A intersection B is 90 minus 70, that will be equal to 20. So there are 20 students who like both the subjects. So this is the way to solve the question with the help of inclusion and exclusion. Let's take some more example to clear this concept. Okay, the next question I am getting, I have already done this question for you. The next question I am getting is, there are 100 persons and we take a survey, and from the 100%, 70% said that they like red color, 50% said that they like pink color. The question asked that how many persons like only pink color. Okay, the same question repeating, that 100 persons are there. Some persons liking red color, some persons liking pink color, but there may be some person who are liking both the colors. So the question is asked that how many persons are there who like only pink color, they do not like the red color. To solve this question, we have 100, that is N of A union B, the total element in the set, that will be equal to N of A. N of A is 70, the first set who are liking the red color. The second set, N of B, is 50 who are liking pink color, and I don't know how to find this only pink color, so let us state with the formula. The formula is saying 100 equal to 70 plus 50 minus N of AB. Okay, and what will I get? 120 minus 100. So N of AB is equal to 120 minus 100, that will be equal to 20. So there are 20 students who are liking both the colors. Now I want to know that how many students like only pink color. to find this one, only pink color, wherever you get the question, wherever you get the word only in the question, what you have to do, I have discussed one operation with you, that A minus B, the set difference operation. What is the set difference operation? The element which are in set A but they are not in the set B. Okay, so to find this, n of A minus n of B. What is n of A? N of A is the person who are liking pink color. This set. There are 50 students who are liking pink color, but from these 50 students, there are 20 students who are liking both the colors. So what we are going to do? We are going separating the common persons who are liking both the colors from the set who are liking the pink colors. So there we get the answer 30 who are liking only pink color. So this is the way to find the only colors, yeah, only set, number of element in single set. What you do, you use the set difference operation to get this one. Okay, so this is the way you can solve this type of question. I have two more examples to solve. I will solve one question and I will solve next question you will solve by your own. I will explain you and you are going to solve it by your own. Okay, so I have done this one, and now I am going to take this example. And this example you are going to do with your own. Okay, and if you can't do this question, please comment. I will explain you how to do this question. Okay, so let's take this example. What the question say? Question said that there are a survey in the class and 70% students passed in English. There are two subjects, English and Maths. The question is saying 70% students passed in English, 65% students passed in Maths, 27% student failed in both the subject, 240 students total passed in both the subject. So you have to find the total number of students. Okay, so how to find the I have to find the total number of students. So in this question I don't have this, I have to find this element. Okay, what I firstly have that 27% students are there who failed in both the subject. So I can find the percentage the student passed in any subject. Okay, so what is A union B? Well, how can I get? That is 100 minus 27. So there are 73% students who passed in either subject or in Maths, in one subject or two subjects. There are total 73% students who are even passed. Okay, so we get the answer n of A union B is equal to 73%. Firstly I get this, and now n of A, the set, the student passed in the English subject. So there are 70% students who passed in English subject, plus n of B is the set who passed in Maths. So there are 65% students who passed in Maths. So n of A plus n of B minus n of A intersection B. Look, I don't know how many students passed in both the subject. Okay, I have the number but I don't have the percentage, and I am calculating on the percentage. So I am getting n of A intersection B in the format of percentage. Okay, so what will I get? N of A intersection B is equivalent to 70 plus 65 minus 73. So there are 62% students who passed in both the subject. So we get a value that there are 62% students who passed in both the subject English and Maths, and in the question there is given that there are 248 students who passed in both the subject. So with help of these two statements we can find the total number of students. For example, if I assume that total number of students are Y, okay, and 62% of students passed in both the subject. So I am taking the 62% of Y, and that will be equivalent to 248, because the number are given in the question that there are 248 students who passed in both the subject. Okay, so I can get the value of Y, that will be equal to 248 into 100 divided by 62, and when you solve this you will get the answer 400. So there are 400 students in the class, and this is the analysis of the result. The 70% of students passed in English, 65 passed in Maths, 27% students failed in both the subject, 248 students passed in both the subjects. So we get the total number of students, that are 400. This is the way to solve the question. Okay, and this is a question you have to do by your own. The question said that there are 100 total students, in which 50 students use the college library, 40 students use their own library, 30 students borrowed the books from other students, 20 students are there who use both college library and their own library, 15 students are there who use own library and borrowed books, 10 students who use college library and borrowed books, and you have to find that how many students are there who use all three ways to read a book. That means they are using college library plus own library plus the borrowed books. You have to find this one. Thank you for watching my video. If you like my way of teaching, you can like, comment and share the video, and don't forget to subscribe our YouTube channel.